The topic which we are going to see is the engineering and medical application of laser. We all know the characteristics or properties of laser. Based on this characteristics, where we are using the laser, that is the thing which we are going to see. The first property is we all know that it has a it does not diverge at all. That is, it has an arrow band with an angular spread. And then, so due to this property, we are using in a communication. That is, to transmit thousands of programs and transmitting signal from a longer distance, we are using this long haul communication. That is the main application of this property. And then next one, the property is it is not absorbed by a water. So it is not, since it is not absorbed by a water, we can use in a underway communication between the submarine, which is very useful for a military purpose. And then due to the high penetrating power, it is used in to cut the diamonds or put holes in a diamonds. It is also used in drilling a minute holes in a cell walls of a human body. This is the medical application. And then due to a high penetrating power, it is used in cancer treatment, and also it is used to destroy the tumor cells. Due to the property of directionality, it is used to produce a laser gun and laser torch, and then to do the microsurgery and also a bloodless surgery. And then it is also used in laser printing and in computer storage devices. And due to high intensity, we can use this, and directionality, we can use a laser in an endoscopic application in a medical field. Apart from this, we can use this in a laser in the application, in engineering application like material processing and then CD writing, holography, etc. So what is in a material processing? First we can see what is a laser heat treatment. See, when a laser light of high intensity, directionality, and coherence is focused on a particular area, even of a small micrometer size, for a longer time, that particular area alone it is heated and the other area will not be heated. So this is called laser heat treatment. That is, here a light energy is here converted into a heat energy by this process. So we are calling it as a laser heat treatment. Now we can see how this laser treatment techniques is used in engineering application. That is, we are using this one in applications such as surface hardening, coating to make a glassing of a material, alloying, cutting, welding, drilling, and etc. This process is called material processing. For this, we will be using a lasers such as ruby laser, NdArc laser, and CO2 laser. So the techniques which we used, that is instrumentation. The instrumentation for material processing consists of laser source. It will be having laser source, then we will be having a shutter, and we will be having a focusing lenses, and then apart from this, we will be having a shielding gas jet or powder feeder to remove the molten material or smoke or fumes which is produced during heating. And then we will be using assisting gases such as air, nitrogen, oxygen, or helium. And powder feeder used to feed a material powder whenever it is necessary. This is the basic arrangement of material processing, that is laser heat treatment. And then when a laser light is switched on, the light reflected by the plane mirror is made to pass through the shutter, and the intensity of laser is controlled by the shutter, and then focusing assembly makes the full laser to fall on a specimen. Now the specimen is getting heated, it gives us smokes, fumes and molten material, and it is removed by a shielding gas jet, and in turn makes the laser to fall on a specimen without any disturbance. So this by this process the material can be drilled, cut, put a hole, etc. effectively and it easily. This is the process of what? laser heat treatment. And apart from this, we are using this laser in a microelectronics. That is, we can make a photo masks, that is photosensitive substrates on IC structures like this. And also we can use it for writing and reading a CD, DVDs, and also designing a thin film circuits. This is the circuit which is produced from it. And then in a thin film technology, as a laser is a high directional and the beams are used in to trim the portion of a film or a metal or a semiconductor film deposit on a dielectric substrate by many other evaporation techniques. And also it is used, it can etch a number of micro components over a dielectric substrate to form a IC. That is, it is used to build an IC, capacitor, resistor, etc. And also it is used to write the data in a CD, that is creating a data by using a pits and lands, and low power laser can be used to read that data. This is called a laser cutting. So the laser is used as a tool to cut a thin metal sheet by properly focusing onto the laser on a particular area for a longer time. Due to this, a thermal effect of layer sheet is cut as shown here. That is, as per a design which we need, we can cut that substrate. This is laser drilling. That even to a 0.2 to 0.5 micrometer thickness, we can drill it in by using a laser without any other hardened surface. This is laser welding. We can weld it by using two metals by using a laser welding. So advantages of material processes: there is no damage on a material, time consumption is less, no need of machining after the processing, that is after welding we can directly use for an application, and no need of vacuum as an electron beam material processing. Here we no need of any vacuum condition.